Thank you. Hi, everyone. Let's see where we can take this. So often, I guess, this is kind of us, and we accept that the world is not perfect and security is not really perfect. And we say this is fine. But at some point, maybe you reach this conclusion where everything is on fire and everything is terrible. And there were enough recent events where this happened. And it's kind of like we don't want to get to this point. And obviously, there is no silver bullet to avoid that. And everybody trying to sell you a silver bullet to make that happen it's not going to work. But I want to look a bit at what you can do around auditing and figuring out like what has happened to your system and probably what hasn't happened. Or ideally, what hasn't happened to your system. So, if you have any questions in the middle, since time is not so long, just post them to Slido, and if we have time at the end, I will answer them live. Otherwise, I will just tweet out the answers. So if you go to Slido and my Twitter handle, then you can just post a question there. Just write any sensible question to that, and I will come back to that at the end. By the way, did anybody figure out why I'm using that Twitter handle and that name for Slido? It's kind of like in the first slide as well. Did anybody see the connection to my name? Anybody old enough to remember Rod 13? Where you rotated the letters? So if you take my last name and rotate the letters by 13, this is what you get. And the nice thing about Rod 13 is if you rotate by 13 again, you're back at the original. That's kind of how I got to that. Anyway, so let's jump into Auditd. Who's using Auditd already actively? Very few. Okay. So Auditd is, this is from the man page of Auditd. Auditd is the user space component to the Linux auditing system. And it's writing out records, to disk what has happened. And you basically define it to, configure or to collect various pieces of information that are relevant for your instance. So for example, you could access or monitor the access to files or to the network or to system calls or whatever user action people are taking. All of that can be collected by Auditd and can then be logged. What Auditd is, by the way, not doing is it's not blocking anything. It's not like SE Linux. It's not securing your system. It's just collecting what you are doing. It's just keeping track of that. And it pretty much looks like this. You have an application in user space and it calls the kernel. And in the kernel, you have the system calls and you have user, task, and exit. Those are the three hooks basically which you can use. And if you have an exclude rule, and if any of these actions passes through the exclude rule, then it will be collected by the auditing daemon. So basically you define your rules and everything that passes through your rules will be collected by Auditd and will be written out as a log file. Which looks something like this. Let's make this slightly larger. So you have aureport. If I would be in with the right user. Obviously, a non-root user will have a hard time with that one. What aureport basically is doing is it's telling you when it ran. So this was only running like a minute or so. But you can still see it's collecting a lot of information. It's basically parsing that file, the Auditd log file. And you can see, for example, we made 3 configuration changes. We had 14 login attempts while it was running. We have 3 users in our system in total. We have 5 terminals. We have 3 host names. All of that is being extracted from the logs. How do the logs look like? You can use ausearch. And then, for example, raw to see the raw events that you have in the background and what is going on here. So for example, here, this is one entry and you can always see type, some daemon ended. And then you see there was a message, Auditd, this is the Unix timestamp and this is the unique ID, of the operation. And then you can see the operation terminated, some process and the whole thing was successful. You could, by the way, have the same timestamp and ID if multiple exclude rules would let your process pass through it. So we saw the 3 things where you could pass from the kernel to the logging. If 2 or 3 of them match, you would have the same timestamp and ID for that. And that is one of these elements. And you can see this is another one here. The user started something and here we had some reference that user sudo bin referenced something. And all of these are kind of the raw events that you have. You can also use that to filter, for example. You could say, I only want to see the successful events, and there will be quite a few successful events. You could also say, you don't want the successful ones. I think for that one, we will need sudo as well. And then you can see we didn't have any unsuccessful events in our log here. So all of this has been collected. This is working reasonably well. But you can see the lines are always very different. Like this line has totally different parameters than this line here. And if you want to centralize that, because you probably have more than one instance, it could be a bit of a pain to actually do that. So, how to understand the logs? There is a documentation from Red Hat which actually describes like all the elements that you can have in there. I could basically show that quickly as well. So if you head over to the Red Hat documentation, they have a pretty good description of all the elements in that log and how to see how that's working out. If you want to define the rules, in the GitHub repository of Auditd, you also have a couple of rules which you can define what Auditd should be doing for you. For example, we will get back to that one for a power abuse, where basically a root user is accessing stuff in the home directory of a not root user. And this is one of the rules that Auditd could be working with, for example. So you can see, always when the process exits, we want to monitor the home directory. If the user, that is calling that has a low user ID for a user in the developer group, or like in a higher user group is the owner of that, then you want to basically log that event. And we put it under the tag power abuse. And this is how you could work with that and filter down on that later on. So this is one of the rules. The syntax is maybe slightly arcane, but you have a couple of examples in this repository here that you can just reference and try to get started with. One thing that is still a bit work in progress are containers. So if you have namespaces and are using Docker, saying like which event came from which container is sometimes a bit tricky, and it's a multi-step approach, and it's still work in progress for Auditd here. So the general idea now is we want to collect all of these things, and we also want to centralize that, because you probably have more than one instance and you don't want to have it just in one place. So how do you centralize that? That is where I come into play. So I work for Elastic, the company behind Elasticsearch, Logstash, Kibana. You're probably using us somewhere for logging already. And we also had that need where we wanted to centralize our security events for that. And how to do that? I build highly monitored Hello World applications, and I want to show you how to do that very quickly today. So I assume some of you are familiar with the infamous Elk Stack, Elasticsearch, Logstash, Kibana, which is like one sitting on top of the other. We've added some more components later on. So we have something called beats now. The problem with beats is there is no B in Elk. So that's why we call it Elk B or Belk, which looks something like this. You can see it's a B and it has the elk horns. But marketing didn't want to stick with that because we always are about scaling, and this isn't very scalable. If we have another component and another letter, we would need to redo the entire branding. So we just call it the Elastic Stack, but doesn't really matter here. And you have this stack then. And what the idea is, you have the beats, which is like a lightweight agent or shipper, which is written in Go. So you have a native binary to forward your events, store it in Elasticsearch, and then you can visualize it in Kibana to centralize that. And all of the stuff that I'm showing you here is open source. You can just use it, change it, do whatever you want. The first thing we try to do is we try to write a module for FileBeat. So we have something called FileBeat, which is basically tailing files, forwarding them over the network, and centralizing them. The main thing is we always need to parse the log events. And if you look at the raw log events that we had here, you can see these are probably very hard to centralize because all the lines are totally different. And how do we actually parse out the relevant information? We write a regular expression to do that. Who likes writing regular expressions? Anybody? Okay, it's the Stockholm syndrome, right? Where you got so used to writing regular expressions that it's just part of how you approach stuff. And for this one here, we did build that module, and we collected some good information out of that, but it was always very painful to write those regular expressions. Just to give you a quick idea of what we are collecting in there, by the way. So let's head over. So this is based on our auditing event. Since I've stopped Auditd and I only ran it like 12 hours ago, we need to switch the time frame. And you can see this was when Auditd was running, and we collected a bunch of information here. You can see, for example, these are all the things or the kinds of events. That was the type field, the very first one that we have parsed out. You can see which users have been causing how many events. You can see these are the raw events down here. Here I do have a map. How do I get to the map? So in some events we have an IP address, and then we just do a geo-IP lookup to draw that out. We could actually try to see how good the map is today, because geo-IP always depends. More or less, I guess. I was in a hotel pretty close by, so yeah, more or less. You get the city, you get the region. So this is where the events were coming from. So this has been parsed out just from the logs. And by the way, you can combine that with other logs. So for example, you have the auth log, and you could figure out, for example, if somebody has to try to SSH into your instance. Since this is just a public instance, you can see SSH login attempts. You can see over the last 12 hours, this is when I set up the instance. This is when somebody else tried to log in, because you can see those were failed login attempts. And you could see what usernames, for example, they tried to log into that instance. And you can see where they're coming from. So for a change, it's not the Russians, but the Chinese and the Koreans. Let's see, it is South Korea at least. And you can see this is where the SSH login attempts were coming from. But this is just a reverse lookup. And this is just in the auth log. So you can combine the Auditd log and the auth log, for example, to see, okay, somebody tried to SSH into the instance and suddenly they were successful. And afterwards we could collect events with Auditd. So all of that can be collected and is doable. But it's still kind of painful to do that. We always try to kind of dog food that stuff ourselves, or maybe you like the phrase, drink your own champagne better, because that's probably nicer. So we have a cloud service, and for that cloud service, we're kind of picky to figure out all the security events. And that's why they came around and said like, well, we want to use Auditd, but all that parsing isn't working out so well. And we want to get more information out of that. So what we came up with, we kind of wrapped Auditd into a beat, and we call it auditbeat. So it's using the same syntax and it's using the same base library, but it's being wrapped, and you don't need to write out the file and then parse it back. Rather than that, we can just collect the information in a more structured format directly. Also, we've added some other events around it that made our life easier. So we can correlate events, we can resolve the user IDs to usernames directly. We don't need to parse it out or write it out to a file and parse it back, but we can send it to the Elasticsearch directly. It doesn't use eBPF, but it's kind of closer in features than a lot of other things that we have. The good advantage of Auditd is that it works on older kernels as well. It's easier to configure, and since it's written in Golang, it should be reasonably secure, hopefully. And it does support Docker and Kubernetes all the way. So you can enrich all your events and know where from which container or from which Kubernetes namespace they have been coming from. So what we've done is, we took libaudit and have a Go library around that, and that is communicating with the Auditd framework. That is basically the base library that we're using to extract from the kernel the messages, and then just write them out in a structured format directly. That's the general idea. And what you can do then is, let's just head to a dashboard. So we have auditbeat. These, by the way, are all pre-built dashboards. I'm lazy. I didn't build them myself, and you don't have to either. You can just use whatever is available. So you can see at night, I started my instance. We collected a couple of events right here, and since then it has been a bit more quiet. Then I did something again here. So you can just see the general spikes of, for example, connections and executed tasks and everything we have collected here. You can see which rules were basically collected. So you can see user logins, user space, etc. All of this has been collected from Auditd, and you can see the raw events down here, and you can see how they are doing. And before I talk too much about that, let's do something else. Let's look into the actual configuration file. So let's say we want to use an elastic admin. And we have, audit beat, audit beat YAML. This is where the configuration file should be living. And this is just a configuration of how to put this into place. So you have a few things which are kind of the configurations around it. For example, you can rate limit the events, because otherwise you might be generating too many events and might be overloading your instance. You could rate limit that. I set it to 0, so we don't rate limit right now. I'm also not collecting the raw event messages because it might just be too much traffic. And after that, we have the actual raw rules that we want to collect. So for example, here we are watching a file, pamconf. So every time somebody reads, writes, accesses, or changes an attribute on that file, we want to collect that, and we write out an event that is called pam access with a tag. And then you can filter down on those to find those. Probably pam.conf is not a super valuable file to monitor, but whatever important configuration files you have in your system, for example, that you want to monitor if somebody changes or accesses them, that is something that you could put into place. So we can look into the raw events for that one here. So I'll head over to the raw events. You can see in the last 12 hours, we had 180,000 events because, well, this is a Hello World application. I'm just collecting lots of stuff here. You would need to fine tune that for a production setup probably. Let's switch over to the last 15 minutes to see just what we had here. So for example, I could say here, I want to have, I'm accessing my file. And then you can see we have all of these events here. And then you could just either in the search bar search for pam.conf, or in a more structured way, you could also say, since we have these tags, and then you need to remember, what was my rule? I always forget what I call my rule. It's pam-access. And then you can just say, this is the rule I'm interested in. And ideally, if you run that, you can see this was just me, where I've accessed that file. And in that one event, you can also see a couple of other pieces of information here. So you can see the auditing information. So you can see the primary actor who actually did that was the Elastic admin user that I've been using. You can see how I did it. I ran cat. And what I did. So the primary object that I was monitoring was that pamconf file that I've shown you before. You can also see there are some other pieces of information around it. First off, for example, we can enrich every element with the host. So here you can see where is this even running on what kind of host. So for example, if you know we have some security issue just on one specific operating system or one specific version of it, you could totally filter down to that. So for example, here I could say I'm only interested in Ubuntu 18.04.2. If you click on that plus, it will add an additional filter, and it will only filter down to instances from that specific version of the operating system, which doesn't change much. I only have a single instance which is running that version, but you get the general idea how to drill into that. And the second thing we are enriching here is the metadata from the cloud provider. So if this is running on a cloud provider, you can just see This is running on AWS. You can see the instance ID. You can see this is running in Ireland on a T2 micro instance. All of that can be enriched. If this was running in Docker, which it's not, but if it would be running in Docker, you could get the Docker metadata as well. So you would know which base image you have for your Docker container or which labels do you have applied for your Docker container. If you are using Kubernetes, you could get the Kubernetes namespace and similar pieces of information. So that's all pretty easy to collect and show. Since I've shown the power abuse before, let's quickly run through the power abuse to see what we're getting out of that. So let's assume we have our Elastic admin user and he's curious. So he just looks into the home directory and he finds the Elastic user and he assumes, well, maybe the Elastic user has something interesting I want to see. And then he can see, okay, there's a secret txt file from that user. Maybe I want to take a look. So will this work? Hopefully not, because it is the permission denied. Let's try with sudo again. Oh yeah, and you can see the file actually contains my secret, which unsurprisingly, there was a secret in it, and now we want to figure out who has accessed that file. So we have been tagging that with, I think it was power abuse. So what you can do is here you can just switch the label and say there should be something called power abuse. And if you filter down to that, you can see there were some before, but this is probably the last one that we are interested in. And you can see again, this was the user doing something. So you would know where to look. You can see how they use cat. This was the thing that we were monitoring, the secret txt file. And then you can see the various pieces of information around it that might help you. So, for example, you can see the process ID and you can see the actual command that I have been running, and we have added various tags to that so you could filter down. So you can see who has been doing what and what they have been abusing or not abusing in your system. So that's pretty easy. Another thing that you might be interested in, let's say, is somebody opens a socket and wants to run something you don't want to have there. So, for example, if I run netcat on port 1025, anybody has their laptop handy or something on their phone to talk to me? So the instance name is, you can just telnet to, it's just like my Twitter handle .wtf, which is like the right domain for any demo. If you just telnet here, you should be able to connect. And then you can write whatever you want and it should pop up on the other side. So if anybody has a laptop or anything handy, you can just telnet to that instance on port 1025 and the messages should then pop up. And we will be monitoring both which sockets have been opened and also which connections have been coming into that instance here. While you run that, let me quickly jump back, not to disrupt the process. No, this is not where I wanted to go. Let me quickly jump back to the configuration file here. So for example, to log which sockets have been opened, I'm just saying the system call is -s socket, and then I just tag that with socket open. For example, if you connect to a system out, you could just you just need to know the right system call, and then you can monitor any system call on your system. So the open socket is the one that we're interested in. Let's get rid of this one because we don't need it. Let's say we want just the open socket. And ideally this, my browser is hanging. Okay, this refreshes. And then you could, for example, see here, these are all the sockets that we have been opening. And for example, in that one here, you see, where, what, when, has been opening sockets. For example, here you can see, okay, this beat that is also monitoring my instance has been opening a socket. And you could then just drill down into those. But because all of that configuration is kind of a bit arcane, we have added another kind of module into that thing. This is not based on Auditd. This is kind of like a nicer syntax, and just something we check in the background with auditbeat automatically. But we can, for example, check which hosts do you have, which users, packages, logins. And for example, every 2 seconds, I check which processes do I have running and which sockets do I have running. And for those, we have proper dashboards pre-built, where you can just see what is going on your instance. So if I head over to the dashboards again, and rather than looking at the raw event, I'm looking at the Auditbeat dashboards again. You could just say, like, let's look at the sockets. You can see these were all the sockets that were opened. And actually, that's not the dashboard I wanted. Auditbeat. If I could type Auditbeat. I want the socket dashboard is the one I want. Here you can see these are all the sockets that have been opened, and the connections. Because of the screen scaling, this is slightly cut off now. But you can see which IP addresses have been talking to you, which destination ports have been working here, and you can see our 1025 is already sticking out here. And I could just click on that plus here to filter down on that one. And you can see we have, in the last 15 minutes, 4 sockets were opened, and you can see this is when they were opened. And you can see, first here we have the listening command when our netcat opened, and you can see this was the actual command that has been running. And then you can see inbound connections, where people connected to that, and you can see from which other IP addresses to our system people opened the socket connection. And you can just monitor, okay, something bad started running on 1025, and you can see when was it started. You can also unfold that to actually see, okay, we have a socket opened, and you can see all the details of like who has been doing that. You can see the Elastic admin user has been opening the socket. And afterwards, you can also see like which inbound connections have been coming into that one socket. So if a remote shell is starting to pop up on your instance on one specific port, you can then figure out which specific user opened it and which other systems connected to that pretty easily. So this has been going on. Did anybody write any messages? No. Maybe the Wi-Fi is also blocking port 1025. I've seen it a couple of times that people tried to connect and were not able to. But generally, you should be able just to telnet to the instance, and then it will show any other messages. So if I type other here, it will just pop up and you can have those events. Okay. Since we're running a bit short on time, the final thing maybe we could touch on is every now and then you have like some sensitive files you want to monitor if anything changed on those. So what the file we have, for example, I have a very professional website here, which is just welcome. But maybe somebody wants to change the website. So somebody could just walk in and say like, var www HTML index HTML. We want to change that site. It's read-only, sorry. Let's change something on here. Let's say, welcome to and suddenly your professional website is not so professional anymore. So somebody just changed something. And you might want to figure out what changed on your system. And to do that, Auditbeat has another thing, another module we call file integrity. Basically, you can define watch this folder, exclude any files, like these are the temporary files VI is creating because I don't want to create any noise from VI changes, and watch for any changes. Basically, what we're doing is we're hashing every file in there, with SHA-1, which is the default, if it's smaller than 10 megabytes, and we're scanning up to 50 megabytes a second, of files changed. And for that, we can also see in a dashboard, there should be a file integrity overview, this one here. This one will show you, we deleted and moved one file, this one here. You can see it was done by the root user because we were using sudo. And you could see this was on this host, and you can see these were the two files touched. Why do I have a moved and deleted of that numeric file here? Because that's the pattern that VI uses to change a file. It's actually creating a new file and then replacing the original one. So you can see here, this was the file that was deleted, and this was the file that was changed. And you can see the timestamp. This is a way to track like what important files on your system are changing over time. So depending on your operating system, you will have different methods to keep track of file changes. The Auditd features obviously only work on Linux because it depends on the kernel to do that. There is a port to Mac, but it's slightly different and buggy, so we haven't implemented that yet. For the file integrity, that's supported on all operating systems, so you can monitor all the different operating systems, and these are the calls we are using for that. And you could switch out the hashing algorithm as well. For example, SHA-1 is the one we use by default, but this one here, the last one, would be the most performant one if you're worried about performance in that. Okay, we've seen that one. To wrap up, I always compare this a bit to a block of Lego. Like you have a lot of rules you need to put together yourself, but once you have the right rules, you can pretty much monitor whatever you want on your system. So it can be executions of processes, it can be sockets, it can be user actions, it can be logins. It could even by now be stuff like, if I go back here, we could even monitor, for example, packages. Here, in the last 12 hours, it checks you have 620 packages installed on your one instance. You can see when were packages added to your system, and you have a full list including their version. For example, you could figure out, like, do I have Auditbeat installed? And then you see we have one package installed called Auditbeat. This is when it was installed, and this is the version that we installed. This can also be very helpful if you know there is a vulnerable version of one specific package out there. You can just collect that from all your instances and see, like, where is that package still installed, or which package or which instances have already been updated with that. So stuff like that will come in very handy. This is just part of what Auditbeat can collect for you. But you need to kind of configure the right rules, whatever makes sense for your environment. So we've seen Auditd for the raw events and the base kernel module that we're using, and then we are wrapping it into Auditbeat to make collection of events a bit easier. And then we also have thrown in logs and dashboards to kind of like tie it all together and see a bit more what is happening on your system. We're actually using our cloud infrastructure, and we have a couple of thousand VMs and bare metal instances, and all of those are being monitored with Auditbeat, and we have been doing that for quite a while. Sometimes people ask for the specific rules that we have or are using. I'm not sure the colleagues want to put them out, because then you could try to find something that is maybe not caught by those rules, but maybe they will. Yeah, they plan to write a blog post on the actual rules that we are using in production, just to give you an idea what might make sense for us or for you. If you want to try anything out of that, I have all the configuration files and the setup. It's fully automated. That's why I just couldn't set up tonight. It's just a bit of Ansible and Terraform. It will just start the cloud instance, create all the configurations, and then you can just go wild and try to do stuff. If you are looking for alternative solutions, Slack has something very similar, which is called GO-LIBAUDIT, to collect auditing events. And they're also using the Elastic Stack to collect all the security events into that. There is another project on GitHub, from Scribery, which is called aurShape. So like aureport and ausearch. They wrote a binary called aurShape that can export the Auditd logs to JSON and XML. If you really want to use XML, that's the only tool that can do that from what I know. So those are your options to get to those Auditd event logs. And with that, I think we have 1 minute left for questions. Any questions in the room? Or did anybody post anything on Slido?
Are there any questions for Philipp?
No questions here. No questions there. Perfect. Then we're perfectly in time. Thanks a lot.
Okay, then thank you very much, Philipp.